A flying tank, a machine built to glide into battle on wooden wings, was actually tested over Soviet soil. The Antonov A-40 Krylia Tanka was the brainchild of Oleg Antonov, a man who looked at a 32-ton T-34 and saw a glider. He couldn't make the T-34 fly, so he stripped an experimental tanket down to its skeleton, bolted on a biplane, and in 1942, a pilot towed this unholy hybrid into the sky. The sheer structural audacity of attaching a detachable airframe to an armored vehicle, expecting it to land under fire and drive off, defines a specific breed of Soviet madness. This wasn't a one-off fever dream. It was the peak of a decades-long obsession where engineers were ordered to ignore the laws of physics. Imagine being strapped inside a steel box, feeling the entire structure shudder as the tow rope goes taut, knowing the only thing between you and a fiery crash is a set of hastily welded control surfaces. How do you even steer a tank in the air? And what happens when the ground rushes up to meet a machine that was never meant to leave it? Today, 10 Soviet tanks that pushed past the bizarre and into the realm of the almost impossible. Before we start, tell me in the comments where you're watching from, and subscribe so you don't miss which failure takes the #1 spot. Object 287, February 1961. The Soviet Council of Ministers greenlights a new kind of tank killer. The Kirov plant in Leningrad, under Yosef Kotin, gets the job. Their idea is radical. Get rid of the cannon entirely and build a machine around missiles. The chassis comes from the T-64 prototype, the Object 432, a proven mobile base. But the armament becomes an experiment in complexity. There is no turret. Instead, the whole roof carries a rotating platform with a sealed hatch. Inside, a rack stores 15 Typhoon anti-tank guided missiles. To fire, the launcher pops up through the hatch, exposing itself. It can track a target across 200 degrees. Two 73mm Molnia smoothbore guns sit on either side in armored caps with 32 rounds between them. These are backup weapons because the main punch is the Typhoon, a 140mm missile flying at 250 meters per second. Its shaped charge warhead chews through 500mm of steel. The commander-operator aims manually via a radio command link, all while peering through a panoramic sight with a stabilized field of view. A two-man crew sits isolated in the front hull, separated from the robotic fighting compartment. The problem is the guidance logic. Manual command to line of sight means the operator must keep the crosshair on a moving target and fly the missile onto it simultaneously. Engine vibration, dust, and the delay of the radio link turn this into a maddening task. The system demands a level of human precision that combat conditions make impossible. When the missile breaks lock, it becomes an unguided metal tube. The tank loses its primary weapon in a single moment of human error. The launcher mechanism, with its exposed pop-up sequence, adds a fragile set of seals and motors to an already overloaded maintenance schedule. The armor is thick, up to 200mm, with a fiberglass filler on the front hull, enough to stop a 122mm shell. It does not matter. A missile tank that cannot reliably guide its missile is just an underarmed scout. The project limps through testing. A derivative with jet engines, called Object 288, gets sketched out, but the core idea is a dead end. Military planners close the folder. Object 287 never sees service. IT-1. In 1968, the Soviet Union put a tank into service that had no main gun. Instead, it carried 15 radio-guided missiles and a single machine gun. The idea was to give T-62 battalions extra long-range punch. The result was a vehicle that was helpless in an enormous donut-shaped zone around itself. The 3M7 Dracon missile had a minimum range of 300 to 500 meters. Inside that radius, the missile flew unguided for its first second of flight, meaning the gunner could not steer it onto a target. An enemy vehicle that got close was safe. The IT-1 could not shoot back with anything but a 7.62mm PKT machine gun. This dead zone was a tactical nightmare. A tank destroyer that cannot fight anything near it is a liability in any mobile battle. The guidance system added another layer of trouble. It weighed 520 kilograms and used one of 7 radio frequencies to steer the missile by tracking a flare on its tail. At night, the range collapsed to just 900 meters. The crew of 3, driver, gunner, and commander, had to manage an automatic loader that popped the missile up through a roof hatch, jettisoned its storage container, and only then unfolded the fins. 12 missiles were inside the autoloader, with 3 more in an unarmored box on the turret rear. A single penetrating hit, there meant a catastrophic cook-off. Tank crews disliked the low ammo count. Artillery crews, who also manned the vehicle, found it overly complex to maintain. After just 2 years and 220 units built, the military pulled the IT-1 from service in 1972. The surviving hulls were stripped down and converted into BTS-4V armored recovery vehicles. A missile tank that could not survive a close fight ended its days towing broken-down tanks. IS-7. In 1945, Leningrad designer Nikolai Shashmurin began work on a tank that would be immune to everything the defeated Germans had ever fielded. He started with a naval gun. The S-70 was a 130mm cannon converted from a warship, and it fired a 33-kilogram armor-piercing shell at 900 meters per second. This alone created a paradox. To carry such a massive gun and its autoloader, the tank needed a chassis that could support immense weight. So Shashmurin wrapped the IS-7 in a monolithic shell of angled plates, a pike nose 250 millimeters thick on the turret face, 350 on the mantlet, and 150 on the upper hull sides. The tank now weighed 68 tons, yet the designers wanted mobility. They installed a 1,050 horsepower diesel engine, giving the IS-7 a power-to-weight ratio of 15.4 horsepower per ton, superior to most contemporary medium tanks. It could hit 60 kilometers per hour. The fatal equation had been written. The Soviet railway flat cars of the late 1940s could not transport a 68-ton vehicle. Standard bridges could not support it. A heavy tank that cannot reach the front line is a monument, not a weapon. Even its advanced torsion bar suspension and hydraulically boosted controls could not negotiate roads that crumbled beneath it. The tank also suffered from an identity crisis. A breakthrough vehicle armed to blunt the heaviest German tank destroyers had no enemy left to fight. Work stopped on February 18, 1949. Only 3 prototypes had been built, and one now sits in Kubinka, waiting for restoration. Object 279. The project began in 1957 at the Kirov plant in Leningrad, led by engineer L. Troyanov. The goal was a breakthrough tank that could survive a nuclear blast wave without flipping over. The solution was a radical hull shape, thus it looked like a flying saucer. The cast hull was an elongated ellipse with thin curved armor panels designed to deflect a shock wave and reduce the effectiveness of shaped charge warheads. At its thickest, the armor reached 269 millimeters on the hull and 319 on the turret. But the shape that protected it from physics created a mechanical nightmare. The running gear consisted of 4 separate tracks, 2 on each side, mounted on hollow longitudinal beams that doubled as fuel tanks. This gave a ground pressure of just 0.6 kilograms per square centimeter, allowing the 60 metric ton machine to float over mud. The problem was complexity. The hydropneumatic suspension and the 3-speed planetary gearbox with a torque converter were a maintenance black hole. During trials, the low nimbleness became obvious. Turning this 60-ton saucer required immense effort from the 1,000 horsepower 2DG-8M diesel engine, and efficiency loss in swampy areas was severe. The real killer wasn't a design flaw but a political one. On July 22, 1960, at the Kapustin Yar range, Nikita Khrushchev watched a demonstration of new technology. He then strictly forbade the adoption of any tank weighing more than 37 metric tons. The 60-ton Object 279 was dead on the spot. The military also wanted lighter tanks that could safely cross Soviet bridges. The program was terminated. One of the 3 prototypes survives, restored to running condition at the Kubinka Tank Museum in 2022. Object 279. In 1957, the Kirov plant in Leningrad began work on a heavy tank designed to fight where no tank could go: swamps, snow, nuclear fallout zones. Chief engineer L. Troyanov shaped the hull into a cast elliptical shield, 269 millimeters thick at the front, wrapped in thin anti-heat panels. The turret reached 319 millimeters. A 130 millimeter M65 gun fed by a semi-automatic loader could fire 5 to 7 rounds per minute. But the real headline was underneath: 4 tracks on 2 hollow, longitudinal beams that doubled as fuel tanks, hydropneumatic suspension, a 1,000 horsepower diesel, and ground pressure of just 0.6 kilograms per square centimeter, matching a light tank despite the 60-ton mass. The idea was to glide over anti-tank obstacles and soft soil without bottoming out. The problem was turning. The 4-track layout generated 12 times the turning resistance of a conventional tank. In mud, the complex drivetrain bled power, and field repair was a nightmare. 3 prototypes were built, but in July 1960, Khrushchev banned any tank over 37 tons. The heavy tank era ended. The surviving object, 279, sits in Kubinka, restored to running condition in 2022. T-100. In 1938, the Red Army wanted a replacement for the aging 5-turreted T-35 heavy tank. Combat experience in Spain had shown that thin armor was death against even small-towed anti-tank guns. The new specification demanded resistance to 37 and 45 mm guns at any range, and 76 mm artillery at 1,200 meters. 2 Leningrad design teams got the order. One produced the SMK. The other, led by N. Barakov at factory number 185, built the T-100. Both teams actually objected to the original requirement for a 5-turreted monster. The order was reduced to 2 turrets before serious work began. The T-100 still ended up with a front turret carrying a 45 mm gun and a rear turret above it with a 76 mm gun. The front turret's field of fire was severely restricted by the second turret right behind it. This layout forced a long chassis, 58 tons of weight, and a crew spread thin across 2 fighting compartments. The multi-turret concept was already a tactical dead end. It split the commander's attention and added mechanical complexity without a real combat payoff. Torsion bar, suspension, and welded armor were modern features, but the core idea was archaic. In December 1939, the prototype was sent to Finland for combat trials, alongside the SMK and a single turret variant that would become the Kiravi-1. The T-100's poor mobility and divided armament failed to impress. The simpler, better armored Kiravi-1 won the competition outright. Only 2 T-100 hulls were ever built. One was later converted into the Su-100Y self-propelled gun. The other was ordered to mount a 152 mm howitzer in a rotating turret, but the turret was never installed. It ended its career as a fixed pillbox during the defense of Leningrad. The heavy tank itself was never put into production. SMK. In 1938, the Soviet Union wanted a replacement for the T-35, a 5-turret land battleship that was mechanically nightmarish and already obsolete. The specification was brutal: survive a direct hit from a 45 mm anti-tank gun at point-blank range and shrug off 75 mm artillery at 1,200 meters. The Kirov works in Leningrad, under Joseph Kotin, answered with the SMK, named for the assassinated party boss, Sergei Kirov. It was a 55-ton monster with 2 turrets, a short 76.2 mm gun in the upper central mount, and a 45 mm gun in a forward sub-turret. The design meeting had already slashed the required number of turrets from the original madness, shifting to a torsion bar suspension instead of springs. But Kotin and his team saw the fundamental flaw while they were building it. A multi-turret layout distributes the crew, the weapons, and the commander's attention across isolated compartments with terrible sight lines. The hull, stretched to accommodate 2 fighting decks, measured over 8.5 meters long. That length-to-width ratio destroyed its ability to pivot in confined spaces. The turning circle was atrocious. In early 1940, the single SMK prototype, 2 KV-1s, and 2 T-100s were rushed to the winter war against Finland, grouped into a company of the 91st Tank Battalion. The armor was thick enough. Finnish anti-tank guns and machine guns could not penetrate it, but the forests of Summa did not care about armor. The SMK's extreme length made it a liability on narrow forest tracks. It could barely negotiate the turns. An anti-tank mine exploded under the hull, mobilizing the machine completely. The crew could not move it. The massive tank was abandoned in no man's land and sat there unrecovered for 2 months. The single-turret KV-1, born from the same design bureau, had already rendered the SMK pointless. A commander in a single turret sees the battlefield and commands the gun. A commander in a split-hull vehicle fights his own tank's geometry. The Soviet Union built exactly 1 SMK. KV-2. In 1939, the Red Army encountered the Mannerheim Line's concrete bunkers during the Winter War and needed a direct fire solution. The result was a marriage of the KV-1 chassis with a short-barreled 152 mm M10 howitzer housed in a massive, slab-sided turret standing nearly 4 meters tall. The vehicle entered service in 1940, and about 210 were built before production halted the following year. The fundamental problem wasn't the gun. It was the center of gravity. By placing such an enormous cannon and turret structure on a chassis designed for a 76mm gun, the design team created a center of gravity that sat far too high and far too far forward. This imposed a strict operational limit. The turret could only be traversed on relatively level ground. On any significant slope, the lateral momentum and off-axis weight made rotation mechanically impossible, or risked flipping the torsion bar suspension into a fatal bind. The crew fought inside a steel box that weighed about 52 tons, but its mobility was theoretical. The overloaded drivetrain, a derivative of a 20-year-old Holt Caterpillar transmission, shattered itself regularly. Drivers carried sledgehammers to force the gearbox into position. During the Battle of Rexenii in June 1941, the true cost of the design emerged. A single K-2 famously held up an entire German division for a day, immune to every anti-tank round fired at it. But the majority of the 29 KVs lost in that battle were not destroyed by penetrations. They were abandoned after their transmissions failed or their engines seized. It was a vehicle designed as a slow-moving bunker buster, and it was exactly that, a bunker with tracks that could barely move. Production ended in 1941, and the surviving machines faded from combat as their own weight crushed their gearboxes into inoperability. Antonov, a 40 Krylia Tanka. In 1942, the Red Army tried to solve a fundamental tactical problem: how to put an armored vehicle directly onto a battlefield without an airfield. Parachuting light tanks from heavy bombers had been tested, but the crew landed separately, often losing precious minutes or the tank itself to enemy fire. Oleg Antonov took a radical approach. He attached a detachable cradle of large wood and fabric biplane wings and a twin tail to a T-60 light scout tank. The idea was to tow this hybrid glider behind a heavy bomber, release it, and have the crew fly their tank straight into combat, shed the wings, and drive away. To make the 5.5-ton T-60 even theoretically airworthy, engineers stripped its armament, ammunition, and headlights, leaving just enough fuel for a short run. The result was a gross flying weight of 7,804 kilograms. On September 2nd, a TB-3 bomber struggled to tow the A-40 aloft. The tank's blocky, unaerodynamic shape generated extreme parasite drag. The slipstream clawing at the flat turret and hull turned the glider into a massive air anchor. Even with the TB-3's engines at full emergency power, the airspeed bled off to a critical 160 kilometers per hour, and the bomber could barely maintain altitude. To avoid stalling and crashing both aircraft, the pilot, Sergei Anokhin, had no choice but to cut the tow rope. The fundamental flaw was a brutal mismatch between the available thrust and the tank's drag coefficient. No Soviet power plant in 1942 could pull this barn-shaped object through the air fast enough to generate sufficient lift. Anokhin skillfully glided the wingless tank down to a rough field landing and drove it back to base. The project was canceled immediately for lack of a sufficiently powerful tug. T-35. By 1933, the Soviet Union had accepted a 50-ton, 5-turreted giant into production, a machine designed to break through any defensive line. The concept was simple. Put a 76mm howitzer, 2 45mm guns, and 3 machine guns onto a single chassis, then crew it with 10 men. The result was a rolling anachronism. The T-35's armor was a patchwork of rolled plates, mostly 20 to 30 millimeters thick, welded and riveted together. A well-aimed anti-tank round could punch through it, but the real killer was the machine itself. The single M17 aircraft engine, producing just 500 horsepower, had to move 54 tons of steel. The transmission, a complex nightmare of shafts and clutches stretching the length of the hull, was under constant, catastrophic stress. Friction was the enemy. The sheer mechanical resistance inside the gearbox and final drives generated immense heat and wear, leading to stripped gears and snapped drive shafts. When the driver shifted gears, he was not just changing a ratio, he was wrestling a linkage system so imprecise that missed shifts were common, often shattering the gear teeth and immobilizing the tank on the spot. In the chaos of Operation Barbarossa, this became a death sentence. The 34th Tank Division's T-35s rolled out to meet the German advance in June 1941, but most never saw a Panzer. They broke down on the march, their transmissions seized, their clutches burned out. Crews abandoned them in the mud of Western Ukraine, not as casualties of war, but of their own design. Of the 61 built, nearly all were lost to mechanical failure. The T-35's 5 turrets were a parade ground fantasy that never translated into battlefield control. If you enjoyed this video, leave a like and subscribe to the channel. Drop your idea for the next episode in the comments.